This video describes how physicists discovered the limitation of classical physics and developed the main concept of the quantum theory that replaced it in the early decades of the 20th century. It describes these concepts that explain the order of things which they were first discovered. Light behave in some aspects like particles, and in other aspects like waves. Matter, the stuff of the universe consisting of particles such as electrons and atoms, exhibits wave-like behavior too. Some light sources such as neon lights give off only certain specific frequencies of light. A small set of distinct pure color determined by neon's atomic structure. Quantum mechanics shows that light, along with all other forms of electromagnetic radiation, comes in discrete units called photons, and predicts its spectral energies corresponding to pure color and intensities of its light beam. Many aspects of quantum mechanics are counterintuitive and can seem paradoxical because they describe behavior quite different from that seen at larger scale. In the words of quantum physicist Richard Feynman, quantum mechanics deals with nature as she is observed. For example, the uncertainty principle of quantum mechanics means that the more closely one pins down one measurement, such as the position of particle, the less accurate another complementary measurement pertaining to the same particle, such as its speed, must become unknown. A single photon is a quantum, or smallest observable particle of the electromagnetic field. A partial photon is never experimentally observed. More broadly, quantum mechanics shows that many properties of objects, such as position, speed, and angular momentum, that appeared continuously in the zoom-out view of classical mechanics, turn out to be quantized. Such properties of elementary particles are required to take on one of the set of small, discrete, allowable values. And since the gap between these values is very small, discontinuities are only apparent at very tiny atomic scale. Another example is entanglement, in which a measurement of any two-valued state of the particle, such as light polarized up or down, made on either of two entangled particles they are very far apart, cause a subsequent measurement on the other particle to always be the other of two values, such as polarized in the opposite direction. Simply one particle can affect other on. A final example is superfluidity, in which a container of liquid helium, cooled down to near absolute zero in the temperature, spontaneously flows slowly up and over the opening of the container against the force of gravity. We can explain these things in our next video. This is only introduction of quantum mechanics.